Assalamualaikum warahmatullahi wabarakatuh. Hello, we are from Group 6. Here we are going to explain about reliability and validity. But first of all, let me introduce a member of Group 6. There is Kurnia Setyanti with ID number 076, Febriana with ID number 102, and the last is Sofiana Nurul Islami with ID number 123. First, the definition of reliability. Reliability is a constancy of a test to measure or observe something that is the object of measurement. A test can be said to have high reliability if the test can give results that remain the same or consistent. The measurement result must remain the same or relative the same if the measurement is given to the same subject even though it is carried out by different people, different times, and different places. Measuring instruments with high reliability are called reliable measurement instruments. Next, the types of reliability. First is the reliability stability. This reliability involves using the same indicators, operational definition, and data collection procedure over time and measuring them at different times. To be able to obtain stability reliability each time the unit is measured, the score must be the same or almost the same. Next, the represented reliability. This reliability refers to the reliability of each group, thus whether the delivery of the indicators is the same when applied to different groups. The last is the equivalency reliability. Testing reliability by using equivalent measures at the same time can take several forms. The most common form is called the Minute split technique.
Reliability characteristic. A test is considered to have good reliability if it has the following characteristic. First, reliability belongs to a set of test scores, not to the test itself, meaning that a test is said to be good if it produce a fairly accurate score. If the test is given to a certain class, it can also produce a fairly consistent score if it is given to a different class or when given to the same class at different time. Second, a test is said to be reliable if two tests are carried out at different time intervals and show scores that are not much different. Third, reliability can be expressed for two or more independent measurements obtained from the same test for each group. Next is reliability goal. The purpose of this reliability test is to show the consistency of the score given by one scorer with another scorer.
Next is reliability estimation method. Allen and Yen in year 1979 divides three methods to estimate reliability coefficient. The first is test-retest. The retest test method using the same instrument in the same sample group and performed twice with different implementation time. To calculate the reliability coefficient by calculating the correlation of the first and second instrument implementation score with the formula correlation product moment or Pearson. Second is parallel form. The parallel form method using the same instrument in content, material, aspect measure, and also difficulties levels. Testing can be done simultaneously between the first instrument and its parallel. To calculate the reliability coefficient is by calculating the correlation of the first and its parallel instrument implementation score with product moment or Pearson. And third is internal consistency. The internal consistency method using one instrument so that the test only held once. This test requires the cleavage of the instrument to be part of the parallel part. To calculate its reliability coefficient can be used various formulas such as Spearman-Brown and Cronbench alpha. Next is the reliability test formula. First, product moment correlation, or we know Spearman-Brown. We use the formula as follows, where Rxy is the correlation coefficient between x and y. X is visible score 1 and y is visible score 2. Plus n is the number of quotient. Second is KR20. This formula is very appropriate to be used to calculate the reliability coefficient of the objective test, which has a dichotomous score between 0 and 1. The formula as follows, where Rxx prime is the reliability coefficient, n is the number of quotient, Sx squared is total score variance, and p is the proportion of students' correct answer with all of the students, or we know difficulty level that already studied in the previous material. And last is Cron-Patch alpha. To calculate the reliability coefficient of ESI test, we use the Cron-Patch alpha, and the formula we can see as follows, where Rxx prime is reliability coefficient, n is the number of quotient, Sx squared is the total score variance, and Si squared is the variance of each item or pre-existing formula. Then we move to the example. Suppose the egg test is in the form of multiple choice consisting of 10 items, given to 10 people twice. The test result you can see as follows, where x is the visible score 1 and y is the visible score 2. Then to count the coefficient correlation, we can use the product moment correlation formula as follows. And then we substitute n, sigma x, sigma y, and so on. And then we will get Rxy is equals to 0,89. We get the coefficient correlation is 0,89. So the coefficient reliability is 0,89. Reliability coefficient criteria based on Cemari-Mardapi, if R greater than 0,7 and R less than or equal to 1 is categorized as reliable. If R greater than 0,3 and R less than or equal to 0,7, it's categorized as a question need to be fixed. And then if R greater than 0 and R is less than or equal to 0,3, categorized as the question need to be fixed or removed. Because we get R is equal to 0,89, which is greater than 0,7, we can conclude that the test is reliable. Next is validity. Definition of validity. The definition of validity according to Suryabrata is the degree of the measurement function of a test or the degree of accuracy in measuring a level. The validity of a test is concerned with whether the test actually measures the roof to be measured. The definition of validity according to Sujana is the accuracy of the assessment tool against the concept being assessed, so that it's really assessed what must be assessed. The definition of validity according to Kusari is the accuracy, meaningfulness, and usefulness of a conclusion obtained from the interpretation of test score. The definition of validity according to KBBI is true nature according to the available evidence, logical thinking or legal force, valid nature, validity. Based from the definition from the expert above, we can conclude that validity is a standard or basic measure that show appropriateness, usefulness, authentic, that lead to the accuracy of interpretation of an evaluation procedure in accordance with the measurement objectives.
Type of validity of data measurement instrument. According to Suharsini, based on the method of testing, there are two validity, namely external validity and internal validity. We said that the validity is divided into several criteria. Number 1, validity based on the test method, namely, first, internal validity with regard to the level of accuracy of the research design with the result achieved. Second, external validity with respect to the degree of accuracy with which the research result can be generalized or applied to the sample population. Number 2, validity based on how to determine it, namely, first, logical validity. It is called logistical validity because the method of determining is carried out with logistical consideration. The items are arranged logically, consisting of content validity, logistic validity, and appearance validity. Logistic validity can be seen logically that the items are expected to measure what is intended to be measured. Logistic validity is based on theory. Number 2, empirical validity. Determining empirical validity is done by comparing the empirical result of the measurement tools compiled with the result of measurement using other valid tools. Number 3, objective-based validity, namely, first, content validity. Validity is the validity obtained when the tool measures a content area that determines a certain degree. Content validity, among others, is in the field of study. Learning outcome tests, for example, are used to measure the content or objective that have been taught to students. Therefore, content validity is also known as curricular validity. Second, construct validity. Construct validity is the validity obtained when a tool measures a hypothetical tool to a certain degree. The construct is abstract, cannot be observed directly. Only the result or symptom cannot be observed directly. And third, concurrent validity. The definition of concurrent validity is the validity related to the relationship or correlation between score in instrument items and performance or other research object. Concurrent validity was obtained by finding a correlation between the measurement of score and the criteria of the measure that existed at the same time, which were created at almost the same time. And last, predictive validity. Predictive validity is the validity where measure instrument can predict the ability of the individual to work in future situation. This validity is very important for selecting or classifying individual. No instrument has the best predictive validity.
Validity test formula. Calculation of the validity of an instrument can use the product moment correlation formula, or also known as a percent correlation. In the percent correlation, an item is said to be valid if the value of R count greater than R table. There are two ways that we can use to find the calculated R value. That is using the first percent correlation using the deviation, and the second is using the root numbers. Next, the formula is as follows. First, the percent formula with deviation is Rxy equals to sums x times y, and the percent formula with the numbers is Rxy equals to nxy minus sum x times sums y divided by root of n times sum x squared minus sum x squared times n sum y squared minus sum y squared. Next, Rxy is the correlation coefficient. Major scale of x is x minus average of x. Major scale of y is y minus average of y. N is the number of respondents. X is score of each item on the instrument. Y is score of each item on the criteria. Next, after the value of the validity coefficient of each item is obtained, then the above results are compared with the R value from the table at a significant level of 5% and the a significant level of 1% with the F equals to n minus 2. So the criteria are: the instrument is valid if R count equals to R table, and the invalid instrument if R count less than R table. Next, this is a table at the significant level of 5% and the significant level of 1%. And this is test instrument validity criteria. If R value is 0.81 until 1, the interpretation is very high. If the R value is 0.61 until 0.80, the interpretation is high. If the R value is 41 until 0.60, the interpretation is enough. If the R value is 0.21 until 0.40, the interpretation is low. And the last, if the R value is 0 until 0.20, the interpretation is very low. Next, we have a problem example. That is it known that the result of learning motivation questionnaire are as follows. This is the result of the student learning motivation questionnaire for grade 7 of SMP Negeri 1 Semarang. Next, we will do the validity test. First, we make the helper table to know the validity of questionnaire item number 1. Validity test for item number 1. We will using the person formula with the numbers. Then input the numbers into the formula, so we get Rxy is equal to 0.203. From the above calculation, the result obtained R count equals to 0.203. Furthermore, this value was considered with the R table of the product moment at a significant level with TF equals to a significant level of 5% equal to 0.707 and a significant level of 1% is 834. If R account greater than R table level say 1%, greater than R label say 5%, that is can be declared valid, and otherwise, then the calculation of item number 1 is declared invalid because R count less than R table or 0.203 less than 0.707 less than 0.834. For calculating item number 2 until 10, the method is the same as above number 1. Okay, that's all from us. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.